In this video, we will cover some commands that can be used to get detailed information about the hardware available on the system. So the first command that we'll cover is the command lshw. So I will just open it with the command. So it's possible that the commands will not be available by default on your machine. So if it happens not to be available, you can install it with the advanced package manager von Linux. You can use sudo apt install lshw for hardware lister. You can install it this way. Since it's already installed here, then I do not need to install it. And if you're using Fedora or like a Linux distribution that use yum or DNF, you can similarly also do sudo dnf install then lshw then. So basically these commands list all the hardware available on the system, and we can actually already give it a try directly this way. And you'll see it prints out actually a lot of information like description, vendor name, bus information, logical name that shows the path where the device is located in the dev directory, the clock, the capabilities, configuration. It even shows the kernel driver that is being used by this hardware, and so on. So it definitely prints out like a lot of information about the system. But you can notice that here it prints out some warning. Output may be incomplete or inaccurate. You should run this program as a user. So to get accurate information, then it's better to run it's lshw to run the command with sudo or admin rights. Yeah, and then the warnings goes away, and then it prints out all the information about the hardware that has been detected, yeah, by the kernel. So if you want to pass out some of the information in your script, it supports some options to define in which format the result should be printed. So it can be in HTML, XML, or JSON. JSON might be quite handy when you combine it with tools like JQ to pass the output, or save it in the file and then share it so if relevant, right? So these are the supported output formats. That's pretty nice. So basically, if I run sudo ls hardware and with JSON, for instance, then I get all the output as JSON output that I can redirect into a file, basically. So pretty handy in scripts, right? What is very interesting is the classes, because it prints a lot of information. So it might be needed to like filter out or scope specifically what is needed. So for it, there is the class parameter that allows you to define what class of parameter or on which class of devices you want some information. So if I use sudo ls hardware and class, let's say CPU, then it will only print out information related to the CPU, right? And such as like the capabilities of the CPU or the features supported by the CPUs, floating point unit, exception, write protect, and so on. Yeah, and also the configurations shows cores, 8 cores, enabled cores, 8 threads, 8 microcode, 194. So basically, with the class input, you can only limit the outputs, and I can say CPU class and then print out this in JSON, and then I'll get all this information related to the CPU in the JSON format or XML, and then it will also be printed out into XML. And to know which are the classes that are possible, or we can use the lshw with the short. So short gives a very a short overview of all the devices that has been detected, their classes, and if possible, the path of the device in the /dev directory, followed by a description to give you an overview. And the hardware path, it's kind of like, for instance, /0 here, it says /0, it belongs to the class bus and is the motherboard, right? So everything that starts with /0 is on the motherboard, but here basically it's a virtual machine. So you'll notice that a lot of the devices are like Fit.io, which is a virtual machine manager tool for Linux. So everything that starts with /0 is related or is on the motherboard, basically. Yeah. And so on. So it shows like the relationships, kind of the tree, or what is related to what parts, and followed by the description. And you can see that at the end here, /1, it says the power button here. My power button is not on the motherboard because this is a virtual machine and it happens to be not on the motherboard. But other things interesting is like the keyboard, for instance, or the mouse, yeah, or like external ones. So they are not detected as like being based on the motherboard, which is the root kind of the path here. So with short, yeah, not only you get a quick overview of everything that is possible, you also get the full list of the classes of devices. So basically you can use this to run sudo ls list hardware class and then define the class, let's say bridge. And then you'll get all the information related to the bridge class that has been detected. And what is very nice here, it has the sanitize input parameter, and this removes potentially sensitive information from the output. So if the information that is being rendered contains like hardware specific or like exactly IP addresses, serial numbers, or so, it will remove such information from the output that is being generated. So basically that output, you can share it, yeah, with, I don't know, if you need to share those information with someone, then you can use this. So let's say bridge, and then with the sanitize information. And if there is any such sensitive information in the output, then it will get removed. The next tool that will recover is the hwinfo, hwinfo it's written, and that can also, it is most likely not installed by default, and you need to install it separately. And to install it, you can also do sudo apt install hwinfo and or the nf install equivalently, right? And these also probe the hardware to print out hardware information. And this is it also prints like very, even a little bit too much, I would say. Yeah, it's yeah, just too much data. So it's better to know what you're looking for, and then you can filter out and scope to only what is very relevant to you. Otherwise, it prints like a lot, very much a lot. And if it is too much, or if it cannot print everything all together, you can combine the hardware info with the LEDs pager. So then you'll be able to scroll through the pages. There is like kind of classes also, but here it's named hardware item. And these are the possible items that you can specify. By default, it's all, right? But you can, let's say, scope down to only block hardware devices. So I can do hardware info -- block. And then it will only print out information related to block devices, right? So here it prints out let's say here first, the CD-ROM, which is available by default with this virtual machine, disk devices, and also information related to the partitions of these devices. And you can notice that with hwinfo, we even get like the path of this device in the /sys directory. So if I open a smaller terminal here, we can actually list the contents of the /sys and then paste this path, and you can have a look inside it to have like all kind of all details about the different capabilities. If you want directly to look for this information in the file system, then you can grab it from here. And it also provides information about the device file, right? The path in the /dev directory is also available. And the kernel module or the kernel modules being used for this hardware is also defined. So this hardware information tool is pretty handy, and it's very verbose when it comes to the amount of information that it can print out. So if you want just a quick overview, you can use the short option. And this shows like kind of like a summary of what hardware has been detected. And then you can have a quick glance at, So if you have like a red, like redundant disk erase, then you can use the --lsmd, and this will show. But here, there is no such disk array, it's just a VM here. So if I do lsmd, then I just get no outputs because there is none available here. The next tool that we'll cover is the lspci. And the lspci lists specifically all PCI devices on the machine. So I can do lspci, and then it gets a quick summary of all the PCI PCI devices that is being detected currently in this virtual machine. And it has the -m option or mm, and this is for machine readable. So if you add the -m option, it prints out the output is in a format that allows you to parse it easily. So I can combine this, for instance, with the cut command and specify, let's say, the delimiter. Use the long option, delimiter to be a white space, and then the field. Let's say I want the first field. The first field would be like the device. This is the device boss. This is the device number, and this is the function number, right? So boss, device, and function. So everything that starts with 00 here belongs to the same CPI boss, right? And incrementing number here, although the different numbers here specifies different devices, and after the dot, it specifies the number of functions that are supported on this device. So here, if I want to cut out only the boss and device and function related information, then I can combine this way, right? And I will just get this information out. So the -m option, prints out is most suitable to be used in scripts, because it's the data is printed out in a like known format where you can get out the fields that you need more easily. But you'll notice that there is the -v option for verbose mode, and if I use PCI verbose, then for instance, let's say for the capabilities, here it shows access denied, because by default, the tool tries to print out as much information as possible. But for some information, you need a sudo or admin rights, right? So if it's not possible or it's not capable of printing out the information without the admin right, then it will just write like access denied instead. So if we want to see the capabilities of this device, I need to run sudo lspci instead. Otherwise, we also have the kernel module that is being used as a driver basically for the devices, and the one in use. So sometimes it's possible that a device supports, there is multiple kernel modules available for a device, but there will be only one in use for that device. So here there is only kernel module available, and that is the one in use. If we want the capabilities, then I need to run lspci with sudo and then the -v for verbose, and then yeah, get the capabilities information. You can have a look through the different options that are available. Like the -n option shows vendor, or let's say I'll say lscci-n. So instead of if I remove the n, we see the full like this is the vendor Red Hat Inc., for instance. But each vendor has an ID, and if you want the ID to be printed instead of the vendor full name, then you just see, for instance, for the divide 02 function 0, here it is. So this is the vendor for this device, vendor ID. So you can use this if relevant, yeah, practical for scripts as well, because these vendor names with like white space in between is not very nice and easily handleable when you're writing scripts. So this -n option is pretty handy for that. To get, for instance, all the devices from a specific vendor, then you can grab based on the vendor ID using the -n option. And one things that I wanted to highlight as well is how lspci command gets its information, and it's from this file. This file is like a database that contains all the known, a list of all known PCI IDs, like vendor, devices, classes, subclasses, and so on. And it's maintained at this web link here. And this is what it's available on the machine, and this is what the lspci command is using to try to render the information about the device that has been detected on this machine. So we can have a look. If I use less here, then we can have a look into that file, yeah, which contain, you know, the full list of all the known PCI vendors and IDs and everything that is known to the moment where the machine has been installed or coming from the distribution that I have installed. Yeah. And this is where the information are being extracted from and to be shown with the commands. So this is where the file, the database is located. And if you want to update this file, there is the update PCI IDs command. So I can do, I actually need the sudo, right? But I'll type it without sudo, and then you'll see it says it's read only exiting, because yeah, it needs only with sudo, then it will download and update it. So it says done. Yeah, so sudo update -PCI IDs, and then it will update that files. Also from the latest stance given at the link. So you do not need to worry about the link. You just run the update PCI IDs, and then it take care of getting the latest version of the PCI.IDs file, or the list of the known devices. Yeah. The -k that shows the kernel modules explicitly. can use this one, and it prints out the kernel drivers in use for each of the detected devices. Yeah, that's so if I want to know all the drivers that are in use for all my PCI devices, I just need maybe to grab this, or let's say with -E for case insensitive, and I want to grab kernel, and then you get kernel in use, kernel modules. So if I want, yeah, this will get both the modules available and in used for the PCI Express devices, right? And then I can do cut or delimit with column, and let's say I get the second field, then I get the list of the kernels. And if I want to remove duplicate, I add unique, and then I get, yeah, the list of the kernel modules available for all my PCI devices. The next command that we'll cover, there is a similar one for USB, and this lsusb. And this also lists out the USB devices, and similarly you can do lsusb here, and then it shows a quick look of the USB device that are available. So this is a USB hub, and this one is also a USB hub. And basically a USB hub is like a bridge that can be used and on which multiple USB devices can then be connected. And if you want, there is the -T or -3 option that shows the hierarchy of the devices that are available on the system and how they are connected. So these two devices are connected to this USB hub, right? And this one has no device connected to it. And this is the vendor ID and product ID from the USB. And if you want the information from a specific device, you can use the -T option. So I can use -T and specify the information from that specific device. So here it just listed the device, but I can do verbose or -V, and then it shows a lot of information, like all the device descriptors. So if you're familiar with the USB descriptors, then you notice that these are basically the data structures that can be used to interact with the USB. So it prints out like very detailed information about this device. If you're working with a USB device and want to get detailed information about it, then lsusb is your friend. And last but not least, there is the lscpu command that lists information about CPU, lists information about the CPU architecture, right? And so ls CPU by default shows like summary of information about the architecture, the number of bits supported, the indiness, which is very relevant if you're writing low-level codes, but otherwise you won't probably have to worry about it that much. And the number of CPU, and this is actually the number of logical CPU cores. Yeah, because the machine has, let's say here, socket 1, cores per socket 8, core per thread 1. This is the virtual machine, so it's not showing the actual CPU cores, but there is, yes, 1 socket. There are 4 physical cores, and the 8 logical cores are coming from the fact that hyperthreading is enabled in the BIOS. So basically, the 8 is what the kernel is saying as available CPU cores, but these are the logical CPU cores, basically. So the flags are it's equivalent to the features, so all the capabilities supported by the CPU. And here, yeah, it's just showing that the virtualization is enabled. KVM is being the hypervisor. The caches, yeah, data caches, L1 data cache, instruction cache, L2 and L3. The L1 is the fastest and it has the least amount of memory because it's more expensive, yeah. L2 second fastest and L3 third fastest. But the CPU caches are faster than the RAM, and RAM is faster than the internal disk. So the list of the hardware related vulnerabilities known, and if the current CPU is affected or not, and if there are mitigation in case of if the CPU presents such a vulnerability. But this is the standard output. There are like some options if you want to pass or to use the output of the lscpu in a script. There is quite some handy lscpu. First, there is the caches. If you want more information related to the caches, then can you have this to have like more details. So this is L1D, the L1 cache, and D for it's the data cache, and L1I for instruction related cache. But yeah, there is the dash caches option for that purpose. And you can also select specific outputs that you are interested in. So instead of listing everything, you can do, so I'm interested in the name here, and maybe the one size, so one hash size, and those are the two output that will be printed out, right? So it's also practical for scripts. There is also, you can also specify the output that you want. So dash JSON produce the output in JSON format, so you can use this and combine it with JQ to pass your data in scripts as well. And there is the pass option also that allows you to select exactly in which information you are interested in, basically. Yeah, so if I, let's say, CPU JSON, then you get all the fields. Yeah, but with pass, then I can limit. So to get all the outputs that you can select with pass, you need to type lscpu --help. And with the help, then you have the list of the columns that you can select. Yeah, with either the --pass option, or there is also the --extended or -e option. So if I'm just interested in the CPU, the core and socket, then I'll do pass equal CPU core socket, and this will be the only output that will be shown. Yeah, with a comma separated list and one row per CPU core, and the lines starting with dashes are considered like comments, so you can easily pass them out. If I want to use this in a script, for instance, then I can do grep and v for reverse match anything that does not start with a pound. Then I only get the list in which I'm interested in, for instance. So this is the way to do it. And there is the extended, and this displays CPU information in human readable format. And extended also fine. although the extended does not need the grep part. It just prints. It's like a tabular form with some with the names of the columns that I wanted first, and then the list afterwards. Yeah, the parts option is practical for scripts, and the extended is handy for yourself if for human user, to only get a subset of the output instead of the standard output of this command. And yeah, so that's it more or less. And apart from the lscpu commands, it's also possible to directly get information related to the CPU in the proc CPU info file, right? And this is already from the proc file system. And this, it presents one full set of description per detected CPU. Here meaning logical CPU. So here is processor 0, processor 1, processor 2, up to 7. So from 0 to 7, which makes 8 logical CPU cores. So that's it. That summarizes more or less some of the tools you can use to get some information about your system, and to which level of details you want, then you choose the suitable tools, and most likely filter out the scope only to the kind of information you are interested in.